Problem number 14. A disk of a moment of inertia I, mass m and radius r has a cord wrapped around it tightly as shown in the diagram. The disk is free to slide on its side as shown in the top-down view. A constant force of T is applied to the end of the cord and accelerates the disk along a frictionless surface. After the disk has accelerated some distance, determine the ratio of the translational kinetic energy to total kinetic energy of the disk. Problem number 15. The maximum torque output from the engine of a new experimental car of mass m is tau. The maximum rotational speed of the engine is omega. The engine is designed to provide a constant power output P. The engine is connected to the wheels via a perfect transmission that can smoothly trade torque to speed with no power loss. The wheels have a radius r, and the coefficient of static friction between the wheels and the road is mu. What is the maximum sustained speed v the car can drive up a 30 degrees incline? Assume no frictional losses and assume mu is large enough so that the tires do not slip. Problem number 16. An object of mass m1 initially moving at speed v0 collides with an object of mass m2 equal alpha m1, where alpha less than 1, that is initially at rest. The collision could be completely elastic, completely inelastic, or partially inelastic. After the collision, the two objects move at speeds v1 and v2. Assume that the collision is one-dimensional and that object 1 cannot pass through object 2. After the collision, the speed ratio r1 equal v1 over v0 of object 1 is bounded by next inequalities.